more antiderivative / integration exercise. The first integration is the integral of ax to the -4 minus x to the -3 minus 7x to the -2 minus x to the -1 plus e to the x dx. So for the integration, the first step is you take the power and then you add 1 to it and then bring the entire piece to the denominator. So let me match the color. So we have that equals to x to the -4 plus 1 and then a divided by the whole thing, and then minus x to the -3 plus 1, 1 divided by the whole thing, and then minus x to the -2 plus 1 and then 7 divided by the whole thing. And then how about the x to the -1? Is that a power rule? The answer is absolutely not, right? The derivative of x to the -1 is ln, absolute value of x, and then the derivative of e to the x is just e to the x. So we add e to the x and then we add a constant c. Okay, so let's clean up the coefficient. The first one is -8/3, right? So -8 divided by 3, and then we have x to the -3, and then -3 plus 1 is -2, so we have a minus -2, so that will be a plus 1/2, and then x to the -2. And then we have a -2 plus 1, so that is a -1, so that becomes a plus 7, x to the -1, and then minus ln absolute value of x, and then plus e to the x, and then plus c. So let's box that. And then how do I know this answer is right? So all you have to do is you take the derivative, right? So let's check. You take the derivative, you bring the -3 down, so the 3's got cancelled, and then -3 minus 1. And then this, you bring the -2 down, and then -2 minus 1. This, you bring the -1 down, -1 minus 1. The derivative of ln is 1 over x, and then the derivative of e to the x is e to the x. The derivative of a constant is equals to 0. So that's how I check my work. And then moving on to the next example, what do we have? So the next example, we have the yellow one. So how about this? Let's put the radical. Let's rewrite the radical. So we have integral. The radical means 1/2, right? So we have x to the 5/2. All right, and then minus 7 x to the 4/3. And then minus, so that will be a negative exponent, and then x to the -1/2, and then dx. So what's the next step? The next step is you will have to take the power plus 1 and then put that in the denominator. So we take the power plus 1, 5/2 plus 1, and then we put this in the denominator. Hold on, 5/2 plus 5/2, because I'm trying to bring this over for my notes. 5/2 plus 1, and then 1 divided by 5/2 plus 1. And then the next step, 7 divided by, so this we take a 4/3 plus 1, put that in the denominator. And then the last one, we have x to the -1/5 plus 1. And then we put that in the denominator. I know we have a plus c, so we just put the plus c over here. And then let's clean this up. So the next step, we have x to the, so that is a 5 plus 2 equals to 7. So that is a 7/2. And then the reciprocal of that is 2/7. So take the derivative of this, and then you will get this back, right? The fractions got cancelled. 7 minus 2 is equals to 5. And then the next step, we have x to the, this is a 3, and then 4 plus 3 is equals to 7. And then you have 7 divided by that, so you have a 7 times the reciprocal. So what is that equal to? Oh, reciprocal, 3/7. 3/7, so that is equals to 3, right? And then check your work, bring the exponent down, the 3's got cancelled, and then you have a 7/3 minus 1, you get your 4/3 back. And then the next step, plus this is a x, -1 plus 5 is past the 4/5, and then the reciprocal of that is 5/4, so check your work, bring the 4/5 down. the fractions got cancelled, and then that minus 1, so you will get your negative 1/5 back. And then don't forget the plus c at the end. So that's the next integral, the second integral. Moving on to the third integral, we have a big fraction. So the next integral, we have here, we have the integral. I will copy the problem for you. 6x to the third minus 2x squared plus x minus e divided by x squared and then dx. So this one I will split that up to 4 fractions like this. We have integral 6x to the third divided by x squared minus 2x squared divided by x squared plus x divided by x squared and then minus e divided by x squared and then dx. Okay, and then let's clean up the exponents. So we have integral 6x minus 2 and then plus that will be x to the negative 1 power and then minus ex to the negative 2 and then dx. Okay, the integral 6x, so that will be a 1 plus 1, right? So x to the 1 plus 1, 6 divided by that. And then the integral of 2 is equals to 2x, and then the x to the negative 1, is this a power rule? No. This is an ln, absolute value of x, and then minus, so this is a x negative 2 plus 1, and then e divided by that, and then we add a c at the end. 6 divided by 2 is 3, so 3x squared. Is this correct? The integral, the derivative of this, you get the 6x back. And then minus 2x, the derivative of this is equals to 2, and then the derivative of ln is equals to 1 over x, but don't forget the absolute value. And then that I will just keep that in negative 2 plus 1 is negative 1, so negative a minus becomes a plus e, and then x to the negative 1, right? So you bring this down, you get your minus sign, and then negative 1 minus 1 is equals to negative 2. And then you add a c to it. So this is your final answer. Once again, do not forget the absolute value, all right? You don't want to do so much work and then receive a 0 at the end, especially when you are doing homework, when you are doing problems online. If you don't input the absolute value, they will take the entire problem as a 0. Okay, so that's the third integral. So let's move on to the fourth integral. I will match the color for you. So the fourth integral is, we have an integral 3 factors, right? So we have the integral of 3x minus 2 times x plus 1 and then times x minus 1 dx. So this one you have to fully expand this and then fully expand this. So let's say x, you multiply the last 2 factors, x plus 1 times x minus 1, so that is equals to the integral 3x minus 2 times, that is x squared minus 1, right? X squared minus 1. And then you open up these 2. So 3x squared times x squared, you have 3x to the third, and then 3x squared minus 1, and then negative 2 times x squared, and then negative 2 times negative 1, that is a positive 2 dx, right? So 3x to the third minus 3x, 3x to the third minus 3x minus 2x squared plus 2, and then you are going to start using simple power rule. So this is a x to the 3 plus 1, and then 3 divided by that, x1 plus 1, 3 divided by that, x2 plus 1, 2 divided by that, and then 2x, and then you add a c at the end. Okay, clean up the coefficients. You have 3 over 4, x to the fourth, minus 3 over 2, x squared, plus 2 over 3, x to the third, plus 2x plus c. And then by checking your work, you have to take the derivative of that. So once you take the derivative, do you see that all the denominators will be gone once you take the power down, right? So you have 3x to the third minus 3x minus, is this a minus? Oh, this is a minus, right? I just changed that to a plus for no reason. minus, and then you add a 2x at the end plus c. Good. Okay, the last one. The last one has a lot of work. So the last one is right over here. We have integral 1 divided by 2x minus 1 to the 4th power dx. So, negative 4. So negative 4 means, by the way, here, 1 divided by x to the negative 4. So that is 1 divided by 1 over x to the 4. So that is equals to x to the 4, right? So this is just equals to the integral 2x minus 1 to the 4th power dx. And then 2x plus, one of the ways to expand that is you have a 2x minus 1 to the 4th. So that is equals to 2x minus 1 times 2x minus 1 times 2x minus 1 times 2x minus 1. So you have 4 factors to open up. If you don't want to go by this way, you can use the Pascal triangle, which is the reason why I picked this problem for discussion. So Pascal triangle. The top of the Pascal triangle is equals to 1. The next line is 1 plus 1. For each line, we always start at 1. And then the next number is we take the 1 plus 1, which is equals to 2. And then we end each line with a 1. So start with a 1, 1 plus 2, 2 plus 1, and ends with a 1. The next line, 1, 1 plus 3, 3 plus 3, 3 plus 1, and end with a 1. And then the next line, 1, 4 plus 1, 4 plus 6, 6 plus 4, 4 plus 1, and then we answer 1. And this one can go indefinitely, right? And then we take this as the first row, this as the second row, this as the third row, and then this as the 4th row. So since we have a 4th power, and then I will be taking these 5 numbers. How do I use these 5 numbers? So the way we use that is we take that as a coefficient. So 1, 4, 6, 4, 1, 6, 4, 1. We take that as a coefficient. Since the sign is a minus, because we have a 2x minus 1, right? Then the sign alternates as like this, plus, minus, and then a plus. What if that is a 2x plus 1? If that is a 2x plus 1, then this will be all plus. So the first term is 2x. So here is how we use that. So we write 2x to the 4th, and then 2x to the 3rd, and then 2x to the 2nd, and then 2x to the 1st, and then 2x to the 0, which is a 1. And then the negative 1, we take negative 1 to the 4th, and then, since we do the plus and minus, then we don't need to worry about it. Then we do a 1 to the 4th, 1 to the 3rd, and then 1 square, and then 1 to the 1st, and then 1 to the 0. And then this is equals to 2 to the 4th power is 16, right? So we have a 16 x to the 4th, and then minus 2 to the 3rd power is 8, right? 8 times 4 is 32. So we have a 32 x to the 3rd, and then 2 square is 4. 4 times 6 is 24. So plus 24x squared, and then minus 8x, and then we add 1. So this is the integral, because that is the expansion of 2x minus 1 to the 4th power. And then we will be just using a simple power rule. So this one is x. 4 plus 1 is 5, right? So 4 plus 1, 16 divided by 4 plus 1. And then 3 plus 1, 32 divided by that. And then x 2 plus 1, 24 divided by that. And then we plus, not plus, minus. And then x1 plus 1, 8 divided by that. The integral of 1 is equals to x, and then we add a c at the end. So this one we have a 16 divided by 5, and then x to the 5th, minus 32 divided by 4 is 8x to the 4th, and then 24 divided by 3 is 8x to the 3rd, and then minus 4x squared, and then plus x, and then plus c. So this is the very final answer of this integral. So if you take the derivative of this, you can easily get this line back. You can easily get the integrand back. Oh, I've almost forgot the dx. Alright, so that is the end of this video. If you think my instruction is helpful and clear, give me a like, share the video for me, click the subscribe button before you leave, and I will catch you all in the next lesson. Signing off.